and today we'll be presenting on personalization initiatives at our company. The goal of these personalization initiatives is to provide student-specific recommendations in order to personalize their interactions on our website. This work is in collaboration with my colleagues here, Zoha and Zargham. So Chegg is a student hub, mainly catering towards high school and college students. They provide multiple online services such as textbook rentals, homework help, math help, etc. Today we'll be mainly talking about Chegg books, Chegg study, and Chegg tutors. Chegg study mainly helps the student in two ways. Firstly, it has a plethora of textbook solutions, which provide step-by-step walkthrough of the concept used to solve a problem. Secondly, it has experts which are available 24/7 and can provide homework help in a wide array of subjects. So a student can come to the website, submit a question, and can receive a response from the expert in a few hours. Chegg tutors is where students go for one-on-one help with a highly qualified online tutor. So as you can see on the screenshot, they can interact with the tutor like face-to-face or using audio or text, and then they can also use whiteboard, code editor, etc. So both Chegg Study and Chegg Tutors provide person-to-person digital services, which witness asymmetric relationship between the educator and the tutor. These services intend to provide service to the students as soon as possible. These are highly specialized because the educators who are hired to teach on our platform have to pass a series of checks and tests in the topic that they claim expertise in. We at Chegg care immensely about the student's experience. So we know that it's a human-to-human service and mistakes can happen, but we encourage our educators to provide the best they can to the students. Both Chegg Study and Chegg Tutors, the students can come, submit a question, then they are matched with an educator. There is one point that differentiates tutors from study is that the educator has to be online at the time the student submits a question. So this makes it a synchronous service. So the matching between the educator and the student is governed by ranking algorithms. Let me give you an overview of the ranking system workflow. So the student comes, submits a question via Chegg Study and Chegg Tutors. The system then extracts ranks of the educators from an offline model. For Chegg Tutors specifically, this rank might be altered depending on some online features of the educators as well. After this sorted list, this can be further altered depending on some student features. The top educator from the final sorted list of educator then provides the solution to the student's question. The goal of these algorithms is to provide personalized and best possible educator matching to the student to create the best possible Chegg experience that we can give to the student. So I broke the problem into multiple steps. In the first step, we tried to understand the educators and the student sides using a bunch of features. The educators' features can be divided into broadly three groups. The experience and the expertise, for example, how long has the educator been in the system, the number of active days of the educator on the platform, etc. Then there are performance metrics like percentage positive reviews. For Chegg Tutors, like I mentioned, that it's a synchronous service, we have some time-dependent features like their availability status, their response rate within, say, a 6 hours window, and their lesson rate within some time window, these kind of features. Similarly, there are feature groups for the students as well. We look into their engagement with the content and the product. We also look at their retention with the product, and then there are profile attributes like a student is new or not, or the subjects they engage with. So let's go over some of the features. So once an educator provides a solution to the student, they create an impact on the student. We then study their resultant behavior. So we look into the content engagement before and after they receive the response from the educator. So it's likely that a student will engage more with the content after if they were really satisfied with the educator's help. Similarly, they might ask more questions or take more lessons if they felt happy with their experience. So once we had a rough understanding of the features, we thought of building a linear baseline model first, where each educator's score was a weighted sum of the chosen features. So at Chegg, we work closely with the business and product teams. These are the stakeholders who provided help in designing and choosing these features. So we A/B tested the linear model and the model concluded in favor of the test. We saw a lift in the student retention, and as you can see, there is a positive correlation between the student retention and the educator's rank. So higher the rank of an educator, better the experience they provided to the student, hence encouraging them to stay with our platform. So after the success of the linear model, we thought of building a supervised model to further improve the performance and also ingest complex features. So we followed the general supervised pipeline, collecting data of educators and students, feature engineering, model building, model evaluation. There's one extra step that we did for tutors, that after we got the rank from the supervised model, we also added some time-dependent features. On our way, we did a lot of we played around with data a lot and used a bunch of techniques that helped us improving our model. So feature engineering. Let me give an example of one of the techniques we use. So two educators might have 100% positive reviews. One educator might just have 5 reviews in total, the other will have 20. So we kind of give higher weight to the one with the more experience and penalize the one which has lesser experience to leverage the fact that they have been more on the platform for more time. So we had a continuous variable, and the natural inclination is to regress the response against the variables. But with the classifier, we saw that the model improvement was easier and error detection was faster when we discretized the output and then created the classifier. We also did feature quantization, which transformed the features to follow a normal and a uniform distribution. So this kind of makes the features robust against the outliers. And so we did offline testing and compared the linear and the supervised model. As you can see, the supervised model kind of outperformed the linear model across all subjects for the same performance metric. With this, I would like to conclude my talk and hand it over to Zoha, who will talk more about checkbooks.
Thank you, Sakshi. So I'm going to talk about checkbooks today, and my name is Zoha again. So checkbooks is one of our products that students can order their books for the classes. It is a rental-focused business where majority of the students prefer just renting instead of buying their textbook because they can simply return it and don't have to deal with the books they no longer need after the class is over, and it's much cheaper. And some tweets from our students here. The focus of this project was recommending relevant books to students based on the book that they were viewing or had just purchased. And we use a priority algorithm among the association rule-based algorithms. This is one of the more popular ones because it has a good strategy for pruning the exponentially growing candidate space and candidate generation. And it is based on the principle that if you have a set of items, then any superset that you make out of this, if the item set is infrequent, then any superset is also going to be infrequent. Therefore, you can just trim down and eliminate the whole branch. And likewise, if you have item sets that are frequent enough for your purpose, then any item in the item set is going to be frequent. So based on that, that's how it looks for interesting item sets that are frequent enough to happen. It is based on a couple of concepts, and I'm going to go through each of them and explain each of them briefly. The first one would be support, and support basically is the frequency of the items that are happening in the transaction data. It is important because based on the threshold that you set, if the support is too low, the combination happening could be of less interest and it could be random. The other one would be confidence, and confidence basically measure of reliability, and it's confidence of A, B is probability that, let's say, the student would buy book B if they've already purchased book A. And together, confidence and reliability, confidence and support put a good case for presenting that item set to the student. But then lift is also very important, and I want to present lift with a small example here. Let's say this is the data for people who drink coffee or tea or both. And we want to present coffee to people who drink tea. And should we do that? Is that an interesting or a valid, useful suggestion, recommendation to the person? If you look at the support for tea and coffee, it is 15%. Once we look at the confidence, it's 75%. So both support and confidence are high. But once we look at just the number of people who drink coffee, it is 90%. So actually knowing that you drink tea lowers your probability from 90% now to 75%. So these items are actually negatively associated with each other, not positively. And this is something that is used to find items that have a lift of greater than 1 to find things that are positively associated with each other and to present it to the user. So if you look at like something like this is something like our transaction data, and let's say user 1 came in and bought the first 5 books, user 2 the next 2 books, and so on. Once we apply the algorithm, the output would be something like people who buy chemistry also buy biology, and hence we can make it easier for them to find one when they're looking at or just purchase the other one. For this data, the next steps that we did was to pick a threshold on confidence and support, and basically that can vary based on the business, so it's basically user defined. So let's say for this example, we chose 60% or as the support or higher, and we came up with these pairs. But only 2 of the pairs would be something that we would suggest, because biology calculus pair is something that is just very popular, and so many users just buy them, not that they're really associated with each other. There are other benefits to using such algorithms besides just finding it easier for the student to find it. One of them is pricing strategies. So we make sure that books that make the same basket or are likely to make the same basket are priced right, so that we don't lose the customer because the other book is too expensive, or supply management and inventory management where we don't have the other book. So this was actually A/B tested initially in email marketing at Chegg, as in one case we just emailed them the book that they just viewed, and then in the other one we would also show relevant or frequently bought items with that book, and the test won and it became the default at Chegg. With that, I just want to add that students come to Chegg from the time that they begin their classes and buy their textbook to the time that their classes end, using our many services that can help them learn. And at Chegg, we put students first, and we deliver and think of ways to deliver personalized services to them. Thank you so much, and I think it's open to questions.
So there's a graph in the Chegg Tutors presentation that showed educational ranking of the tutors themselves correlated with higher student retention or satisfaction. But there's a big area in the middle here that seems to kind of buck that trend a little bit. Have you looked into why that might be or where that comes from?
We did look. So the educator analysis and the student retention. There are a lot of features that go into it. So we kind of looked at the features that were causing this kind of this kind of shifts like ups and downs in the graph, and then that's what we kind of address in the supervised models in some way, and we kind of try to transform the features so that they act the way we want them to, and address the information as well.
Can I add that just in the real world, it's not usually a perfect world. I think what we observe here is actually pretty good to see that kind of increase in retention, given that retention of a student is tied to many, many factors, even outside of what the educator can do, right? And observing this kind of relationship was really good enough for us to see there's a meaningful.
Just to follow on that, can you give a numerical number, like what's the scale of this increase, percentage-wise?
So we purposely kind of presented it this way because but it doesn't really matter because it can be scaled. There's like score or it's something that we define internally, right? But there is you can just know that, there is an increasing, the rank increases as you go from one side to the other side. And I can say that the model was a bimodal distribution where there were two peaks where you could see there's two different populations of the educator in terms of their ranking quality, their score quality. But yeah, it's something that you can assume 1 to 100.
Just my other question on your textbook. I think these days students buy textbook specific to what the teachers recommend and it's specific to the school, the professor.
Yes.
Does your model consider that? So you might recommend a book that in general people want, but this specific school might use it.
So yes, very good question. So in terms of school specific, once we have more data and we're getting there to actually be able to tell students what their peers are buying from the same school, if we have enough data on that school. But since we don't have enough data on all schools, this is a general one. Still, it's really good because let's say most people who, given the example, have a biology course or have a chemistry course would also probably have the biology course. This would pick it up. It will not be a random relationship because we already take out, with confidence and with lift, we take out that randomness out of the equation. It is still possible that it varies between schools, but this is what we can get out of all the data together, not looking into a specific school. But yes, definitely the model can do much better if we had enough data to look at each school individually.
Question on the prediction of engagement. Your predictive model is based on features produced by professional educators examining the students' interaction with your system. That seems like an expensive way to extract features, and I'm wondering what features are the educators looking at? What are they reviewing, and have you tried building a model based on those features?
So I think so the features that I showed here was built by us based on the data, and then when you're saying educators interact with the students, they get a question from the student and they address to the best possible in their knowledge. And then what we do is when we are hiring those educators, we have a series of checks. We ask them a bunch of questions. So for example, you want to apply as an educator on a platform, for example, in say physics. So you will have a series of topic questions in physics, and then if you pass the test, you will be eligible to teach on our platform. So that's what we do. I'm not sure about what features that we might be.
You were describing building a predictive model for predicting student engagement. Is that right?
So we were trying to recommend So it's the ranking algorithm. So a student submits a question, and then educators are ranked and in a way that's personalized to the students, and then the top educator that has the best possible match for the student then answers the question that the student has.
So this is a way of routing questions from the students to a particular educator.
Yes.
I guess I saw a graph you showed with the y-axis being student engagement.
Retention?
Retention.
graph? Yeah. So here it's the ranks of the educator. So and the performance indicator for the educator that he chose was the student retention. So if you're a good educator, you might have provided very good responses to this, like a variety of students, and they felt that, okay, we are getting the help that we need, and then hence they want to retain the product.
I see.
Yeah, I think it's time for us to pause the discussions now, and and then we can get ready for the lunch session.
Well, let me make a quick announcement. Let's thank. All right, so we have about an hour for lunch. Lunch is out there now, so you can go out and there are tables to sit. On the tables, there are lists of topics for possible discussion. You can just get together with they're not as